Okay, we're going to continue with solving logarithmic equations, just some examples just to get your brain used to the process of solving. Notice here we have two logs of the same base and there's a subtraction sign between them. So this is expanded, we're going to write it in condensed form. So log, and there's that invisible base 10. When there's a subtraction, remember it becomes division. So 6 divide, in parentheses, the quantity x plus 1 is equal to 2. Well, now that we have it in this form, we can write it in exponential form. Here's our base, here's our n exponent, and here's our value a. So remember, b to the n is equal to a. So 10 squared is equal to 6 over x plus 1. And we could go ahead and simplify the 10 to 100, cross multiply and all that. But the other thing that you could do is write this over 1 and then flip both sides. So now you're going to have 1 over 100 is equal to x plus 1 over 6. Well, let's cancel the 6's by multiplying both sides. We multiply this side by 6. 1 times 6 is 6. Okay, and now what we have, we need to get this x by itself. So what you have left to do is, what's the opposite of adding 1? Yep, subtracting 1. So you have 6 hundredths subtract 1, which is 100 hundredths, is equal to x. And 6 subtract 100, so we're going to have x is equal to negative 94 over 100. Those are both divisible by 2, so when you simplify, you end up with negative 47 fiftieths. Okay, the equation down below, notice this is natural log, and natural log has the invisible base e, and we have a plus sign. That means that when we condense it, it's going to be multiplication. So we're going to put natural log, there's that invisible base e, and I'm going to put this bracket right here, negative 3x subtract 5 times 2 is equal to 5. Again, we have it in proper form, so when you rewrite it, it becomes e to the 5th is equal to, let's do the distributive, 2 times negative 3x is negative 6x, 2 times negative 5, then we're going to put subtract 10. And now we're going to get that x by itself, so we're going to add 10 to both sides. That gives us e to the 5th plus 10 is equal to negative 6x. Last step, divide both sides by negative 6. And we have x is equal to e to the 5th plus 10 all over negative 6. And remember, you would simplify, you never leave a negative sign in the denominator. But what I'm going to have you do when you type that into a calculator, use the start with the left parentheses. So the shift or second button, LN, that gives you e to the 5th. Close that parentheses right there, then put plus 10, then close parentheses or right parentheses again, then hit divide negative 6. All right, so x is about negative 26.4022, and that's rounded to the 10,000th place. Okay, that's it for this one. Okay, identify the domain and range of each, then sketch the graph. Okay, here is really key thing. Think about the parent function, and in my room, remember my classroom, very far right graph up, it gives you the parent function of the exponential and the log, just the parent function of the log of x, right? And here I've drawn it right here. Notice, as you read left to right, we've got x values, right? The x values go left and right. Notice on this graph, it's going to get really close to 0, but never touch it. The x's will never cross that y-axis. So for the parent graph, the domain, open parentheses, it'll never touch 0, and on the right it goes on towards infinity. But let's look at the range. The left side, it's going down infinitely, but if we continued infinitely to the right, that would be going infinitely up. So the range of this is negative infinity to positive infinity. But what it's asking for, identify the domain and range of the given. So notice if in the parent graph, the domain is at all the values greater than 0, which is indicated by this interval notation. So you just have to figure out what zeroes out inside those parentheses, what will cause, what value for x will cause the inside to be 0. Well, you could do this. You could set 2x plus 9 equal to 0, subtract 9 both sides, which gives you 2x equal to negative 9, then divide both sides by 2. X is equal to negative 9/2, right? So we know that this whole graph is going to be shifted to the left 9/2. So it's going to be really, the new graph is going to be really close to this negative 9/2, but never touch it, right? The other way to think about this, if you're trying to find x, is just cover up the 2 for a minute. The opposite of 9 is negative 9, but then put a fraction bar. The opposite of multiplying 2 is divide 2. So that's a way to think about it. So we know that if we put in negative 9/2, it's going to be undefined. That's the lowest value, and still that's undefined, but it'll never cross 9/2. So then just put in some values above that, and then you can go ahead and graph. So type in, maybe if that's negative 9/2, maybe you would type in negative 4, negative 2, 0, 2. Whatever you're going to do after that, I'm going to leave that up to you. But the key thing is to find the domain and the range. So the domain in this situation, it's not going to touch negative 9/2, but it still is going to be going in the right, infinitely to the right. For the range, notice nothing has changed. The graph is still going to look like this. It has been shifted down so instead of it touching right here, 1, 2, 3, 4, somewhere in here is going to be the graph. But notice, it still is going infinitely down to the left, and to the right, as we looked, if it's going up or down, it's going really slowly, but it's still going infinitely up. So that's how you find domain and range. How you graph it is you just choose some x values. Choosing appropriate x values would be a good idea. Choose x values, go ahead and plug them into the calculator, get the y values, plot the points, and graph. That's it.